Hello everybody, this is RodLab video tutorial number 7. In this video I'm going to show you some of the taper editing and taper adjustment features in RodLab and hopefully give you an idea how to use them. So first place, this is back to the RodLab home screen. I could come in here, if I click on adjust taper, it's going to ask me what taper I want to do. I'm going to pick a Dickerson 9016. Now I could come in here and make a bunch of changes, manually edit stuff. This isn't the way I normally do it. I usually do it the same dialog is embedded as part of the workflow, both in the bending comparison and in the taper translation. So I'm going to come in here into the bending comparison, pick my 9016 and open this up. And I've already got it set up to calculate a couple bend forms here. And if I double click on this taper, I can look at it, but I can't edit here. This taper is tied to the file on my hard drive, so if I make changes, it'll make changes on my hard drive, and if I screw up, I will screw up the taper that's in my save folder. So I don't want to do that. What I do want to do, I'll highlight it, click Add Analysis Taper, and if I do that, I've got basically a copy. So if I calculate again, these two are right on top of each other, and now I can come in here and I can edit. I'm going to rename this 4-piece. I'm going to keep it as nickel silver. And all I have to do is change number of rod sections from 2 to 4. And when I do that, RodLab will automatically add the hollow tooling, which is completely irrelevant because it's not a hollow built rod. But more importantly, it'll add in the ferrules. It'll go out and based on the location of each ferrule, will add the correctly sized ferrule, or hopefully so. You want to double check, make sure it got the right one for how you want it. And it automatically adds these masses in as well, which I think you'll see is important. So I'm done here. And now I've got the updated, and if I calculate the bend form, you see I definitely added the masses. There's a lot more ferrule mass with these 4, not quite, maybe 8/10 of an ounce, which really is affecting the performance. So what I want to do, try some different options. So I'm going to add another analysis taper, and instead of a nickel silver 4-piece, I'm going to change this to aluminum ferrules. And instead of a step down, I'm going to go ahead and pick a Super Z truncated. So when I added the truncated, you see it pick new ferrules, and when I change nickel silver here, watch the ferrule masses. It's going to take the density of aluminum and calculate the correct mass for each of these. So I click on done, and now I calculate the bend form, and now you see my aluminum, which is the black taper here, is really a lot closer in performance to my original 9016. So that's a good thing, but maybe we can do even a little better. So I'm going to make a copy of this aluminum. I'm going to come in here again, and I'm going to use, instead of doing a dip finish, this varnish density is based on a dip finish, I'm going to do a wipe on, which will take a lot of the finish mass out of the final equation. So I'll do a recalculate again, and what you see now is this green one was my final, and now I've actually got a rod that performs even a little faster than the original 9016. So let's take these other two out. And you can see a little closer. So basically very close performance, but now I've got a 4-piece instead of a 2-piece. So that was one thing I thought was helpful to show. Another thing that I think would be helpful is, let's take a step back. When I look at my taper here, you see it kind of has some waves and bumps. And this is probably not due to Lyle Dickerson's design intent. This is probably due to maybe some differences in the thickness of the varnish and perhaps even to some manufacturing variations. So when I calculate this, what you'll see is I look at my change in my bend angle, I get these wobbles. It's not really a big deal, but if I come in and I put a bunch of curves on here, you'll see it gets a little lost into what's what and a little more confusing. So I don't think these were design intent, so what I'm going to do is I'm going to add an analysis taper again, and now I'm going to come in here and make some edits to this. And instead of changing any of the details about the rod, I'm going to try to change some things about the rod profile. So I click on this Open in Taper Editor, and what that'll do is this will give me a sandbox, is kind of how I refer to it, so I can go in and start making graphical changes to the rod. So the way we do this is there's a couple different methods. I'll show you first. There's a linear method, and what I'm going to do is I'm going to pick a start point, end point, and I'm going to set a bunch of points in between that I want the taper to take. Now when I pick the start point, I'm really trying to echo the taper as it currently is, so I can snap that to the current taper, and I'm going to do that like station and dimension. So click a start point and start right here, and then I'm automatically highlights my endpoint. I'm going to come down to somewhere around here. I'm going to pick that. And now I'm going to pick as many midpoints as I want in between, and I'm going to try to come up with That was pretty good right there. I'm going to try to come up with basically a way to follow the rod but with a straight line. So I think I did that maybe with those 3 points right there. And now I've got this other section here, and if you look, this is kind of curved. A straight line approximation would force me to pick a lot of different points to even come close, and I don't want to do that. So what I want to do is I'm going to choose a 3-point curve here. And I'm going to come up here, and when I make this curve, same thing, I pick a start point, I pick an end point, and RodLab will calculate the points in between. But because it's a curve, I have to tell it how many in between points I want to use, or at least the distance between those points. And that's the fill spacing up here. And I'm going to set that to 1. So I'm going to pick a point here for my start. And again, I'm snapping to the station and dimension, so snapping right to a taper point. And now I'm going to come down about here. I'm going to pick a second point. And I'm going to try to find a point in between that matches the taper curve fairly well. And it doesn't matter if I screw up, I can pick different points. Maybe I come down here and I say that, that wasn't quite right. I'll call that pretty good, and then I accidentally click on another one. I can come back here and hit the undo button, and it'll go back to my previous selection. And now what I want to do is I've got the little end of the taper here that's, I want to catch that with a curve as well. So what I'm going to do is I'm going to click my endpoint here that I already had. I'm going to make it the start point for a new curve. So when I click on that button, the point that I use for the endpoint here becomes the start of the next one. And now it's asking me again to choose an endpoint. And the same thing, I got to try to find that looks like a pretty good approximation of the taper. And I'm going to say done. And now I'm done. So when I come back here and look at my taper, pardon me, I've got the red taper that is my new taper, and the blue is the previous one. So I've cut out some of those bumps and waves and curves. So now when I do a bend form calculation, you'll see I've done a pretty good job of capturing the essence of the rod. But when I come in here and look at the bend angles, they're a lot smoother. So it's not really a big deal. I mean, it doesn't really matter. It's just I don't think you'd ever feel the difference between either of those two rods casting it. It's just a way to come in and help you pick the profile you want. So one more thing I'm going to do, I'm going to come in here and I'm going to take this out as well. I've got these bumps that are for where the ferrules are, and let's just clear the points. I'm going to pick a starting point right about here, an ending point somewhere in here. And I'm going to just try to pick a nice curve to smooth through those. Call that done. And go ahead and calculate the bend form. You see again, I've got a pretty close approximation to that curve. And now if I go ahead and pick a bunch of curves and put them in here, it's a lot smoother and a little easier to understand what's going on. So let me take out the original 9016. We'll try this again. And you see these curves are a little smoother, which again, I don't think that has any effect on the performance of the rod, but it's easier to follow. So if I overload this as I did with the previous rod, it's a little easier to see what's happening in here as you go through the different bending curves. So put that back to a 4. And that's what I wanted to show you for this video. There's a couple other things in here maybe I'll show you real quick. I have a few minutes. Let's come back to this taper. And there's another piece of functionality. I'm going to open again my taper editor. I can do an import. And what this would be is I would take another taper or an existing rod that I'd already built, and I would import a section of that into this rod. And where that would be helpful would be is if I wanted to build a rod that had 2 distinct tips. So if I wanted a 4-weight tip and a 5-weight tip, I could build the 5-weight rod or start with the 5-weight rod, and then I could import a 4-weight version of that rod above the ferrule, so that way you'd be using the same ferrule point, but the tip would be different. So we'll probably do that in a later video. I think that's all we're going to cover right now, and I'm running out of space. So thank you for listening.